Hey, MathKook here. This video contains one of many examples in my Algebra 2 library. The rest of those examples, along with hundreds of other videos, are only available at mathkook.com. Let's MathKook it up. This question says, use row operations to transform the system of equations into a matrix in row echelon form. So we are given a system of three equations here. Let's take a look at what row echelon form is and the steps to help us change a system of equations into a matrix of row echelon form. So row echelon form, we'll quickly go through the conditions. The top row starts with a 1 and has zeros below it. All right, so this row would have, top row would be 1, but it would not have zeros below it. We'll have to change that. The first non-zero number in every row is 1, and it will be at least one column to the right of the first one in the row above it. Numbers to the left of the 1 must be 0. So here's a good example here. So every every row starts with a non-zero number of 1, and those 1s must be to the right of the 1 above it. So, and then notice, every number below each of the 1s must be a 0, which it is in this case. So this is an example of a matrix in row echelon form. We talked about all numbers below each initial 1 must be 0, which happens here. If a row contains all zeros, it must be the bottom row, which happens in this example. All right, so now let's take a look at the steps to transform a matrix into row echelon form. So the first step is to write it as an augmented matrix. So writing it basically like this here. So, and then we're going to make the leading number in the top row a 1 if possible, which it is going to already be a 1 in this example. So we don't have to worry about that. Step 2 is use the first row and row operations to make leading number in second and third rows is 0. So we use the second row and row operations to make the second number in the third row a 0. So we'll go over that in detail. And if there's another row, you would do the same thing for step 4 and step 5 for each row. If there's a leading number other than 1, multiply that row accordingly to make it a 1. Okay, so if you want to take a screenshot of this, go for it. I'm going to erase both these charts here and then start doing the work to put this system of equations in row echelon form. All right, so the first step is to write this matrix here as an augmented matrix. So we're going to write 1, -3. So I'm just looking at the coefficients here, and then 2 and 6. So this is 2 and 6. Next is 1, 5, 4, and then 14. And then lastly, the bottom equation, 3, -1, -1, and -10. All right, so our first step is to make both these two numbers here zeros. Now we have a 1 as the leading coefficient in the top row, which is great, but we want both these numbers to be a 0. So I always tell my students to do both these at the same time. All right, so I'm going to write those in blue actually. So we're going to make those both a 0 at the same time. All right, so to do so, we're going to use the first row. So what do we need to multiply row 1 by to cancel out this 1? Well, hopefully you said -1. So we're going to go negative R1 plus R2, and then we are going to rewrite R2 because we get to pick which row that we want to change or rewrite. And then same thing for row 3 here. We want to make this a 0. So we're going to multiply the top row by -3 and add it to row 3. So it'll be -3 R1 plus R3. All right, so let's go ahead and do the work for that. Now, row 1 is going to stay the same, so we're just going to rewrite row 1 here. Now, let's rewrite row 2. So we're going to multiply row 1 by -1. So -1 times 1 is -1, plus 1 gives us a 0. And that was the whole point. We want a 0 right there. And then we just kind of go through all these numbers and do the same thing. So -1 times -3 gives us +3 plus 5, which is 8. And then negative times 2 is -2 plus 4, which gives us 2. And then lastly, -6 plus 14, which gives us 8. All right. And then we do this computation here. -3 times R1, so -3 times 1 is -3 plus 3, which gives us 0. Again, that was the whole point. We want 0 here and a 0 here. All right, and then we keep going here. So negative 3 times negative 3 is positive 9 plus negative 1, which gives us 8. Next, we do negative 3 times 2, which is negative 6, minus 1, which gives us negative 7. And the last one here, we have negative 3 times 6, which is negative 18, plus negative 10, so that would be negative 28. So next, we want to make this 8 right here in the third row a 0, because under any non-zero number, the leading number here, this 8, we cannot have a number below it that's not 0. So we want to make this 8 a 0. So we have to use the second row to make this a 0. You don't want to use the first row because that'll introduce a number here, and we worked hard to get this to be a 0, and we want to keep it a 0 to put it in row echelon form. So we have to use the second row. So what should we times the second row by so that it'll cancel out, this 8 will cancel out with this 8? Well, this one's pretty simple. We just want to times the second row by negative 1. So we're going to do negative R2 plus R3, and we will rewrite R3. So let's go over here to the top right. Now the first row, we didn't do anything with that, so we're just going to rewrite that one. So 1, negative 3, 2, and 6. The second row, we're also just going to rewrite because remember, we're only changing the third row. The one I boxed is the one we're changing. So we're going to have 0, 8, 2, and 8. So 0, 8, 2, and 8. All right, so the third row, we're going to times the negative, the row 2 here by negative. So negative 1 times 0 is 0, plus 0 is 0. And that's good. We want that first number to stay as 0. Now we're going to do the second number here. So negative times 8 is negative 8, plus 8, which is 0. And that was the whole point. That was why we were doing this step. Next, negative times 2 is negative 2, plus negative 7 gives us negative 9. And then the last one, negative times 8 is negative 8, negative 28, which gives us negative 36. All right, so our matrix here is almost in row echelon form, except the leading term, the leading number, like the leading non-zero number, I should say, must be 1. So we just need this 8 to become a 1. So I'll underline that. We need that to become a 1, and we need this to become a 1. And going back here, I'm going to underline the 8 because that's what we changed. That was the whole point of doing this second step, to make this 8 a 0, which it is now. All right, so we're almost there. We want this 8 and this negative 9 to become 1s so that our matrix is in row echelon form. So what should we multiply row 2 by here so that this becomes a 1? So we're going to multiply it by 1/8. So it'll be 1/8 R2. And then on the same step, we're going to make this negative 9 a 1 as well. So we're going to multiply that row, the third row, by negative 1/9, and then R3. All right, so let's go ahead and rewrite these two rows here, and then the first row just stays the same. So we will write that as 1, negative 3, 2, and 6. Okay, so now we're going to distribute the 1/8. 1/8 times 0 is 0. 1/8 times 8 is just 1. 1/8 times 2 gives us 1/4. 2/8, which is 1/4. 1/8 times 8 is 1. Nice. Now we multiply the negative 1/9 to the third row here. Negative 1/9 times 0 is 0, times 0 again is 0, which is nice. And then negative 1/9 times negative 9 is 1, which is the whole point of that step. And then negative 1/9 times negative 36 is negative 36 over negative 9, which is positive 4. All right, so now our matrix here is in row echelon form, which is what they were asking us to do. So it took a series of about 3 steps here, and we finally got our matrix into row echelon form. So this here is our answer. Hey Kook, if you found this video helpful, hit that like button, subscribe, and drop a comment. For unlimited access to all of my Algebra 2 videos, visit mathkook.com. Thanks for watching.